Hey guys, Wes here. In this video, I want to talk about the idea of blue-green deployments. So we'll talk about what blue-green deployments are, how it can be a useful strategy for enabling zero downtime when deploying new code, and we'll also look at how we can actually implement a simple blue-green deployment strategy in AWS. So I hope you guys are doing well. I wanted to make another video in sort of the DevOps space about an idea that's been around for quite some time called blue-green deployments. So the main idea with blue-green deployments is that essentially we have two instances of our application running at any given point in time. We have, let's say, a blue instance which is sitting idle, and we have a green instance which is receiving all of our traffic. And the idea here is that when we want to release new code, we can deploy that to the blue instance in this case that's running idle, and when we're ready we can cut over traffic from the live instance, the green instance, over to blue, and then our clients essentially see that new application code with no downtime between the existing application running our legacy code to the blue instance in this case running our new code. Now there are several different ways to actually implement this in practice. One way that we'll look at in this video is just simply updating the public DNS records to point from the server running our old code to the server running the newly deployed code. There are some things to keep in mind here though. For instance, we'll have to set a really low TTL on those DNS records in order for our clients to actually cut over and see the new application very soon after we've deployed it. The problem there though is that we don't really have any guarantee that our clients will be respecting that low TTL, and so there are more sophisticated approaches we can take here. We could put a load balancer in front of a private network and then change the private DNS records. We'd have complete control over respecting the low TTL in that network. The other thing to keep in mind here that adds a bit of complexity is changes to our database, and particularly updates to the schema. So one way to actually manage this is to release changes to our schema through database migrations separately from our application code. And one way that we might do this is to actually run our database migrations with a version of the schema that supports both the legacy code as well as the new application code that we're prepared to deploy. And then we could cut over the database migration before we cut over our application and ensure that the underlying schema supports the legacy version of the application, and then as we cut over, ensure that the schema supports the new version of the application. Another thing to keep in mind here that is pretty neat is that we can implement a sort of hybrid canary deployment strategy by using weighted routing. So we might choose to route, say, 5 or 10% of our traffic over to the new instance while we sort of observe the behavior and make sure that there were no breaking changes with this deployment. If there were, we have mitigated the effects by essentially routing only a small percentage of our clients to that new code, and then we can easily roll back simply by, again, routing back to our legacy application. So with that, let's take a look at a practical example using AWS with Route 53 and two EC2 instances running an ultra basic Express API. Okay, so the first thing that we'll look at here is a tmux session. On the top pane, I have a shell on one EC2 instance, and on the bottom pane, I have a shell on a separate EC2 instance. But both of these instances have an Express API running on them, or have the ability to run an Express API. So I have an API version 1 and an API version 2 that we can run on our blue and green instances respectively. So if we just take a look at what's running in version 1, it's a bare bones Express application. It's going to simply be responding to requests to root with hello from your API version 1. And on our second EC2 instance, we'll be running a version 2 of our API, which is identical except for the fact that it will send the string hello from your API version 2. Now you'll notice that these are running on port 3000, and I have simply updated the tables to route to port 80 from port 3000. So any requests that come in for port 80 on either one of these servers will route to port 3000. So I'm going to run Node API version 1 on the first EC2 instance, and we're going to run version 2 of our application on the second EC2 instance. So now let's head over to Route 53 to look at how we set up routing to each of these two instances. So this particular example will illustrate how we can achieve blue-green deployment by simply updating DNS routing with Amazon Route 53. So you'll notice that I'm hitting demo.productivedev.com, and you see we're getting hello from your API version 1. And then over here, we can see that I have two A records, one for blue.productivedev.com and one for green.productivedev.com. And these are pointing to the public IP addresses for each of those two EC2 instances respectively. And then you can see I have a couple of CNAME records. And these are for demo.productivedev.com, and what we've done here is actually set up a weighted routing policy, and in this case I have a weight of 1 headed to blue.productivedev.com and a weight of 0 heading to green.productivedev.com. I also have a TTL on these CNAME records of 10. So it should take about 10 seconds for those to actually expire whenever I decide to switch from green to blue or vice versa. So we can see when we're hitting demo.productivedev.com, we're getting version 1 of our API. And now what I'll do is I'll simply drop the weight down to 0 on the blue.productivedev.com instance, and we'll come over to the green instance and we'll set a weight of 1. And so with those switched, now shortly when the TTL expires, we should now be hitting green.productivedev.com when we visit demo.productivedev.com. So we'll refresh this a bit. And in just a few seconds here, we'll see this switch. Okay, and now you can see we're hitting API version 2. So what's nice about this, again, is that we have no downtime, essentially, between switching the server that we're pointing to here. The other thing we can do here is we can set the weights to some other values here to sort of create a canary-style deployment. So let's say that we set weight on our green instance to 1 and weight on our blue instance to 9. And we'd wait for the TTL to expire here again, and the effect would be that we'd be sending approximately 10% of our traffic to green and 90% of our traffic to blue. And this could be used for a period of time for us to evaluate to make sure that everything is working properly on whichever instance we switched over to before we cut over all of the traffic. Now this is a really super simple, sort of crude approach to blue-green deployment, but I just wanted to use it to illustrate the example of how we could set up a really simple style of blue-green deployment just using DNS record updating in Route 53. The real point is that we can essentially divert traffic using weighted routes in this case. We could do this with an application load balancer as well, and we could point to more sophisticated infrastructure on the back end, like different target groups in an ECS cluster. But the real point here is just to demonstrate how useful blue-green deployments can be and how easy it is to do things like rollbacks, for instance, or begin to set up canary-style deployments when we want to route only a fraction of our traffic to one application or another. And so this is probably just one of the most simple ways of setting up this type of deployment strategy in AWS.